In the endless silent dark between the galaxies there is a secret. It is a secret kept not by design, but by its very nature. It is an ancient presence, older than the stars themselves. We have felt its influence for nearly a century, a ghostly hand guiding the grand cosmic dance of celestial bodies. We have mapped its domains, vast invisible empires of gravity that hold entire galaxies in their ethereal grip. We call it dark matter, a name that confesses our own ignorance. But what if this presence is not a diffuse gentle cloud of exotic particles? What if it is not some new, undiscovered force of nature? What if the darkness is not empty but filled with predators? Monsters born in the first infernal second of creation. Silent, invisible, and wandering the cosmos for eternity. These are the primordial black holes, and they are everything we fear. They are the universe's oldest ghosts, and their story is not one of gentle mystery, but of unimaginable violence and a threat so profound it redefines our very concept of cosmic safety. And the truth about them, the final terrifying revelation, is far worse than we could have ever imagined. To understand this terror, we must first journey to the edge of a galaxy. Picture the great Andromeda spiral, a spinning pinwheel of 100 billion stars, its majestic arms glowing with the light of young blue suns rotate at a speed that defies our understanding of physics. According to the laws of gravity, meticulously crafted by Newton and refined by Einstein, the stars on the outer fringes should be moving much slower. They should be like children on the edge of a merry-go-round, flung off into the intergalactic void, their grip on the galaxy too tenuous. But they are not. They hold fast, moving with an impossible velocity. In the 1970s, the astronomer Vera Rubin stared at this paradox. She measured the rotation of galaxy after galaxy, and the result was always the same. The visible matter, the brilliant stars, the glowing gas, the shimmering dust, was not enough. There was simply not enough gravitational glue. It was as if an invisible puppeteer was holding these galaxies together, their strings made of gravity, their form utterly unseen. The calculations were undeniable. More than 80% of the universe's mass was completely, utterly missing from our sight. A colossal phantom, a cosmic ghost, haunted every corner of creation. For decades, the leading theory has been that this dark matter is composed of weakly interacting massive particles, or WIMPs, hypothetical subatomic motes of dust that do not interact with light, drifting through the cosmos and through us like spectres. We have built colossal detectors deep underground, shielded from cosmic rays, vats of liquid xenon waiting for a single telltale bump in the dark. We have spent billions of dollars and decades of our brightest minds' time listening for a whisper from this invisible realm. And so far the silence has been absolute, deafening. This persistent quiet has forced scientists to confront a more unsettling possibility. An idea first proposed not in the age of supercomputers, but in the era of slide rules. An idea conceived by the brilliant minds of Stephen Hawking and Bernard Carr in the 1970s. What if, they asked, the missing mass isn't a new particle at all? What if it is something we already know exists, but in a form so ancient, so compact, and so alien that it is hidden in plain sight? What if the dark matter is composed of black holes? Not the familiar behemoths born from the collapse of giant stars, but something far, far stranger. The stellar mass black holes we can now detect are the titans of the modern universe. They are the magnificent corpses of suns that lived fast and died young. When a star at least 20 times the mass of our own sun exhausts its fuel, its core succumbs to the crushing force of its own gravity. The resulting implosion is so complete, so absolute, that it tears a hole in the very fabric of space-time itself, creating a singularity. These are the gravitational monsters we see at the centres of galaxies, the engines of quasars, the partners in a gravitational wave ballet that sends ripples across the universe. They are loud, disruptive, and relatively young. But primordial black holes are different. They are of a different epoch. They are not the children of stars, for they were born before the first star ever ignited. They are relics from the very first moments of the universe's existence. To find their birthplace, we must travel back in time, back before the galaxies, before the atoms, before light itself could even travel freely. We must journey to the first microsecond of the Big Bang. Imagine a scene of unimaginable energy and density. The entire observable universe, all the matter and energy that would one day form trillions of galaxies, was compressed into a space smaller than a single atom. This was not a uniform, placid state. It was a roiling, violent quantum soup, a maelstrom of energy fluctuating wildly from point to point, creating momentary peaks of density so extreme they defy comprehension. Think of the surface of a stormy ocean, a chaotic canvas of waves. Most are unremarkable ripples, but occasionally, through a rare confluence of forces, multiple waves combine to form a single, monstrous rogue wave. In that first fraction of a second, the universe was that stormy sea. In some exceptionally rare regions, the density of this primordial plasma could have spiked so dramatically, so intensely, that gravity simply overwhelmed all other forces. In these infinitesimally small pockets of chaos, matter and energy collapsed directly into black holes without ever having been a star. These were the primordial black holes, forged not in fire, but from the raw potential of creation itself. They were born fully formed, perfect singularities in the first chaotic breath of time. And because they were born from these random fluctuations, they could come in an absolutely astonishing range of sizes. Some might have been truly microscopic, possessing the mass of a large asteroid, but compressed into a volume smaller than a proton. These tiny singularities would be gravitational ghosts of the highest order, drifting through space, their presence betrayed by nothing but their gravity. Others could have been more substantial, carrying the mass of a mountain or a moon, still no larger than a grain of sand. Still others could have been giants, with the mass of 1,000 suns forming the seeds around which the first galaxies would eventually coalesce. This theory presents a chillingly elegant solution to the dark matter mystery. The universe doesn't need a new particle, it just needs its own ghosts. An ancient population of black holes, scattered like cosmic dust, collectively providing the missing gravitational pull that holds the cosmos together. They do not emit light. They do not reflect light. They do not block light in any obvious way. They are simply points of pure gravity, pure darkness, perfectly fulfilling the job description of dark matter. They would be wandering through the halo of our own Milky Way right now. Countless billions of them swarming in the dark, passing through our solar system, even passing through the Earth itself entirely unnoticed. The idea is so compelling, so beautifully simple, yet it opens a door to a new kind of cosmic dread. The universe we thought was largely empty is, in this model, a minefield, a dark forest teeming with invisible, indestructible spheres of crushed reality. The fear here is not of the unknown particle, but of a known entity in an unknown and terrifying context. We know what a black hole is. We understand its power to shred, to spaghettify, to consume, and this theory populates the darkness with them in uncountable numbers. But the true terror of the primordial black hole is not in its passage, it lies in its mortality. For these objects, these perfect remnants of creation, are not in fact eternal. They are ticking clocks. And this is where the genius of Stephen Hawking returns to our story, not as their originator, but as their executioner. In 1974, Hawking produced one of the most stunning theoretical breakthroughs in the history of physics, uniting quantum mechanics and general relativity. He proved that black holes are not completely black. They glow. This phenomenon, now known as Hawking radiation, is a product of the quantum world. The vacuum of empty space, according to quantum field theory, is not truly empty. It is a seething foam of virtual particles that pop into existence as matter-antimatter pairs, exist for a fleeting moment, and then annihilate each other, returning to nothing. This happens everywhere, all the time. It is the baseline hum of reality. But at the event horizon of a black hole, something extraordinary can occur. If a pair of these virtual particles appears right at this boundary of no return, one particle might fall into the black hole while the other escapes. The escaping particle can no longer annihilate with its partner. It becomes real. To an outside observer, it appears as if the black hole has emitted a particle. But this energy cannot come from nothing. It is borrowed from the black hole's own mass. The black hole shrinks, ever so slightly. It is a process of cosmic evaporation, impossibly slow for the giant black holes we see in the sky today. A solar mass black hole would take longer than the current age of the universe trillions upon trillions of times over to evaporate a single atom's worth of mass. They are, for all practical purposes, permanent fixtures of the cosmos. But this is not true for their primordial cousins. The rate of Hawking radiation is inversely proportional to the black hole's mass. The smaller the black hole, the hotter it is, and the faster it evaporates. This changes everything. This transforms them from passive, silent wanderers into something far more sinister: cosmic time bombs. A primordial black hole with the mass of a large mountain, still smaller than an atom, would have a temperature of billions of degrees, but would radiate so slowly that it would take many trillions of years to disappear. But what about the smaller ones? What about a primordial black hole with the mass of, say, a mid-sized asteroid, around 1 billion tons? Let's do the calculation. A billion-ton black hole, compressed into a space far smaller than any atomic nucleus, would have been radiating energy away since the moment of its creation. For billions of years it would have been a faint, imperceptible glow. But as it shed mass, its temperature would rise, and the rate of evaporation would accelerate slowly at first and then catastrophically. In its final years it would shine with the power of a star. In its final hour it would outshine a galaxy. And in its final second, in the last fleeting moment of its existence, all of its remaining mass would convert into a ferocious, explosive burst of energy. A single, billion-ton primordial black hole, evaporating today, would release a flash of gamma rays equivalent to thousands of thermonuclear bombs. Now, consider the timeline. The universe is approximately 13.8 billion years old. Any primordial black hole created with a mass less than that of a large asteroid would have already evaporated. They would have fizzled out of existence eons ago, leaving no trace. Any primordial black hole with a mass significantly greater will continue to exist for eons to come, silent and dark. But there is a critical threshold, a sweet spot. A primordial black hole with a mass of roughly 10 to the power of 12 kilograms, the mass of a small asteroid, would have a lifespan of approximately 13.8 billion years. This means that primordial black holes of this specific mass, forged in the first second of time, would be reaching the end of their lives and exploding right now, all around us, in our own galaxy. Suddenly, the silent dark is punctuated by microscopic, ferocious detonations. The universe is not just a minefield of passive gravitational objects, it is an active war zone of expiring relics. We have searched the skies for decades for unexplained short-duration gamma-ray bursts, flashes of high-energy light with no obvious source, no colliding neutron stars, no collapsing hypergiants. We have found them. Are these the death cries of primordial black holes? The final violent exhalation of a creature born at the dawn of time? It is a tantalizing and deeply frightening possibility. A single one of these explosions, occurring within our solar system, would be a significant event. Occurring within the orbit of Jupiter, it could potentially pose a risk to satellites and astronauts. But this is only the beginning of the horror. We have only been considering the small ones. Let us now turn our attention to their larger, more stable brethren, the ones with the mass of a planet or even a small star. These objects would be completely stable on human timescales, their Hawking radiation utterly negligible. They would be perfect dark matter candidates, invisible, gravitationally powerful and long-lived. They would be swarming through the galactic halo, a silent, invisible tide. So what is the problem? Why should we fear these passive, quiet relics? Because the universe is a very large place, but it is not infinitely empty, and eventually one of them will cross our path. Imagine a primordial black hole with the mass of the Earth. Its physical size would be no bigger than a marble. It would be travelling through the galaxy at hundreds of kilometers per second. It is not glowing. It is not radiating. It is a bullet made of pure space-time curvature. Now, imagine this marble-sized planet mass object strikes the Earth. The encounter would not be the explosive impact we see with an asteroid. It would be something far stranger and far more complete in its destruction. The primordial black hole would not stop. It would not slow down. It would pass through the Earth as if it were a ghost, but its gravity would not be ghostly. As it entered the Earth's crust, the immense tidal forces surrounding this tiny point of super-concentrated mass would begin to tear matter apart at the atomic level. Rock and iron would be stretched, compressed, and heated to incandescent plasma. The black hole would drill a perfect surgical hole through the planet, its passage marked by a cylinder of vaporized matter millions of degrees hot. It would enter through the Pacific Ocean and exit through the Atlantic in less than a minute. The entire transit would last mere seconds, but the aftermath would be apocalyptic. The planet, having had a marble-sized hole of pure annihilation punched through its core, would be in a state of catastrophic shock. The energy deposited along the transit path would be unimaginable, equivalent to the detonation of trillions of tons of TNT. This energy would create a seismic shockwave that would propagate outwards from the entry and exit points, triggering earthquakes of a magnitude that would register on a whole new scale. Every fault line on the planet would rupture simultaneously. The planet's crust would crack like an eggshell. Supervolcanoes across the globe would erupt in unison, blotting out the sun with a planetary shroud of ash. The oceans would boil where the object entered and exited, sending tsunamis of superheated steam racing around the globe at the speed of sound. The planet's magnetic field might collapse, leaving us exposed to the raw solar wind. The very rotation and orbit of the Earth could be altered. It would not be an extinction event. It would be a sterilization event, a planetary reset button pressed by a ghost from the beginning of time. How likely is such an encounter? The probabilities are thankfully low. If dark matter is indeed composed of these objects, estimates suggest that a planet-mass primordial black hole might pass through our solar system every few million years. The odds of a direct hit on Earth are lower still, but low is not zero. Over the vast timescales of galactic history, such impacts are a statistical certainty. Perhaps this is an answer to the Fermi paradox. Why is the universe so quiet? Where are all the other intelligent civilizations? Perhaps life does arise on countless worlds, develops intelligence, and builds civilizations. And then, one day, without warning, their world is silently and efficiently erased from existence by a passing relic of the Big Bang. A cosmic game of Russian roulette where the bullet is invisible and has been travelling for 13.8 billion years. This is the fear. It is the realization that the cosmos is not a benign, empty stage upon which we play out our brief existence. It is an ancient, dynamic, and profoundly dangerous environment. It suggests that our planet's apparent stability is a fleeting illusion, a lucky break in a cosmic shooting gallery. The threat is not from a distant exploding star or a predictable asteroid. It is from an invisible, silent, indestructible object that could be, right now, just outside the orbit of Neptune, heading our way. There would be no warning. We would never see it coming. Our first and only sign of its existence would be the moment the world ended. But how can we possibly know? How can we test this terrifying hypothesis? The search is on, using methods of detection as subtle as the quarry itself. One of the most promising techniques is gravitational microlensing. As a massive object, even a small one, passes in front of a distant star, its gravity will bend the light from that star, acting like a lens. For a brief period, the star will appear to brighten and then dim in a very specific, predictable way. By monitoring hundreds of millions of stars every night, surveys like the Optical Gravitational Lensing Experiment, or OGLE, are hunting for these telltale flickers of light. They are looking for the gravitational shadow of these passing ghosts. So far, they have found some intriguing candidate events, brief brightenings that could correspond to planet-mass objects in the galactic halo. The evidence is not yet conclusive, but it is tantalizing. Other searches focus on the consequences of a primordial black hole encounter. If one were to pass through a neutron star, it could become trapped by the star's dense gravity and begin to consume it from the inside out. The process would be slow, but it would release a unique signature of energy that we could potentially detect. Astronomers are now searching for old, isolated neutron stars that seem to be inexplicably hot, or that vanish without a supernova. Could these be the victims of an internal primordial predator? And there is one final, audacious idea. Perhaps we don't need to look to the skies. Perhaps we can detect one here on Earth. If a very small primordial black hole, one with the mass of a large aircraft carrier but the size of an atom, were to pass through our planet, it would be too small to cause catastrophic damage, but its passage would not be entirely silent. It would leave a tiny, linear track of acoustic and seismic disturbance, a microscopic shockwave. Scientists have proposed creating a global network of incredibly sensitive seismometers, listening not for earthquakes, but for the faint rumble of a cosmic bullet passing through the heart of our world. This is the precipice upon which we stand. We are caught between two profound possibilities for the nature of our universe. Is the darkness filled with a new, undiscovered form of matter, a particle that represents a new frontier of physics? Or is the darkness simply filled with the oldest things that could possibly exist, holes in reality, forged in the crucible of creation? The first possibility is a challenge to our understanding. The second is a challenge to our sanity. The primordial black hole is the ultimate Lovecraftian horror. It is an entity, ancient, powerful, and utterly indifferent. It follows the laws of physics, but its existence implies a universe far more menacing than we had dared to believe. It embodies our deepest fears: the fear of the dark, the fear of the unseen, and the fear of a sudden, meaningless annihilation. It tells us that safety is a lie we tell ourselves, a comforting story to ward off the truth of the cosmic dark. The truth is that the universe is not empty. It is haunted, and its ghosts are not memories of the dead. They are the architects of death itself, waiting patiently in the dark as they have since the very first light. And the bad news is not just that they exist. The bad news is that they are the very firmament of the universe. We are living inside the graveyard of creation's first, most violent moments. The missing matter has been found, and it is the stuff of nightmares. Our search for knowledge has led us to a truth that we may wish we had never learned. The darkness is not a void, it is a presence. And it is watching. There is no scream because there is no air to carry it. There is no wind rushing past your face. There is only a profound, impossible silence, a quiet so deep it feels like a physical presence wrapping itself around you. You are falling, and below you, or perhaps in every direction at once, it waits. It isn't a hole in the conventional sense, not a pit you can see the bottom of, but rather a perfect sphere of impossible blackness. It doesn't reflect light. It consumes it. It doesn't occupy space. It devours space, pulling the very fabric of the cosmos into its heart like an infinite drain. This is not a destination. It is an executioner, and you have an appointment that you cannot under any law of the known universe possibly miss. The journey towards this abyss may have taken millennia, a silent drift across the interstellar void. But the final moments, the ones that truly matter, will be over in a flash of agony so profound our language has no words for it. We have only a name, a deceptively simple, almost playful term for the most violent process in the cosmos: spaghettification. And for a human body, this transformation from organised matter into a stream of fundamental particles, this ultimate dissolution, takes place in less time than it takes to blink. 0.1 seconds. That is the duration of your annihilation. How can something so total, so absolute, happen so fast? How can the universe, with all its elegant laws and sprawling timescales, conjure a monster that operates on the timescale of a snapping finger? To understand this cosmic guillotine, we cannot simply look up at the stars. We must look inward into the very architecture of reality itself, into the twisted geometry of space-time that Albert Einstein first glimpsed in his equations. For a century, we have chased these ghosts in our mathematics. Theoretical physicists, our generation's great explorers, have spent their lives mapping this treacherous invisible terrain, not with ships, but with the pure, cold logic of their minds. They speak of it with a unique mixture of reverence and terror. It is the ultimate laboratory, a place where the rules of our perceived reality are not just bent but shattered into a million unrecognizable pieces. In their world of chalkboards and supercomputers, they have sent countless imaginary astronauts on this one-way journey, watching as the numbers that describe a human being mass height density are subjected to forces that beggar belief, and every single simulation ends the same way. With a symphony of annihilation played in 1/100th of a second. To begin to comprehend your fate, you must first unlearn what you know about gravity. You think of it as a force that pulls you down, the gentle anchor that tethers you to the earth. Here on the precipice of oblivion, gravity reveals its true terrifying nature. It is not a simple pull, it is a differential, a gradient, a difference in force so extreme it becomes a weapon. As you fall feet first towards the event horizon, the final luminous boundary of no return, the black hole's gravitational embrace is not uniform. The singularity at its heart, a point of infinite density, pulls on your boots, with infinitesimally more force than it pulls on the top of your head. On Earth, this difference, this tidal force, is gentle, raising the oceans in a soft, predictable rhythm. Here it is a cosmic rack, an instrument of torture built from the curvature of space-time itself. You feel it first as a strange, weightless tingling, a subtle, unsettling sensation of being pulled in two directions at once. It is not a pain, not yet, but a deep cellular wrongness. Your body, a magnificent machine evolved over billions of years to withstand the gentle gravity of a single planet, has no defense against this. It is an alien assault on your very structure. This is the moment before the snap, the breath, before the plunge. You cross the event horizon. There is no fanfare, no shimmering barrier. It is a silent mathematical threshold, a one-way membrane in the universe. From this moment forward, all paths, all possible futures lead in only one direction, inward. The light from the distant stars you left behind is now warped into a strange constricting halo above you, a final glimpse of the universe you can never return to. Below there is only the pure, featureless black. And now the stretching escalates with terrifying velocity. The gentle tingle becomes an insistent, powerful pull. It feels as though invisible, impossibly strong hands have seized your head and your feet and are beginning to pull slowly at first, then with exponentially increasing ferocity. The force is no longer just external, it is inside you. Your own skeleton becomes a battlefield. The tidal gradient is now so immense that every vertebra in your spine is being pulled away from the one above it. The distance is microscopic, but the force is planetary. Your joints, held together by ligaments and tendons designed for running and jumping, are the first to fail. Your ankles, your knees, your hips, they dislocate not with a pop, but with a silent catastrophic separation. Your arms are torn from their sockets. You are being unmade piece by piece. Yet this is just the overture. The true horror is far more fundamental. The tidal forces are now working on a smaller scale. They are not just pulling your limbs apart, they are pulling the individual cells of your body away from each other. The integrity of your tissues, the very fabric of your being, begins to dissolve. Your skin, your muscles, your organs, no longer held in their familiar shapes by electromagnetic bonds, start to flow. You're becoming a river of biological matter drawn out into a long, thin stream. This is the moment physics transcends biology and becomes something akin to divine wrathful art. The forces grow stronger with every micron you fall closer to the singularity. What was once a body is now a stream of disconnected tissues tens, then hundreds of feet long, and still, the process of division continues relentless and absolute. The tidal forces these gravitational talons now reach for the molecules themselves. The complex chains of proteins and amino acids that encode your existence are ripped asunder. The very water in your cells is torn into its constituent hydrogen and oxygen atoms. You're no longer you. You're not even a collection of organic parts. You're a flow of fundamental elements, a glowing, superheated filament of what was once a conscious being, accelerating towards the center. And this is where we find our 100th of a second. That final, incomprehensibly violent moment. In the last few microseconds of the fall, as your atomic stream approaches the singularity, the gravitational gradient becomes almost infinite. The force difference across a single atom is now greater than the strong nuclear force that holds its nucleus together. The universe's most powerful glue comes undone. In an instant, every single atom that made you you is sheared apart. Protons, neutrons, electrons, all are liberated in a final cataclysmic burst. Your matter, which once looked up at the stars and contemplated its own existence, is reduced to a stream of fundamental quarks and leptons, a thin luminous thread pouring into the infinite density at the heart of the black hole. From the first dislocation of bone to the final shredding of atoms, the entire catastrophic cascade unfolds in roughly 1/10 of 1 second. Less time than a nervous twitch. Less time than the shutter speed of a camera capturing a child's smile. This brutal efficiency is not born of malice. It is the simple, elegant and terrifying consequence of Einstein's greatest insight that gravity is not a force, but a curvature in the very geometry of space-time. You are not being pulled apart by some cosmic monster. You are being unwritten by the language of the universe itself. The space you are falling through is itself falling, flowing like a torrential river into the singularity. And as that river of space narrows and accelerates, anything caught in its current is inevitably stretched and squeezed into oblivion. This isn't just your body being destroyed, it is your dimension being compressed out of existence. Your three-dimensional form is being extruded through a one-dimensional nozzle. The physics that governs this process is both beautiful and merciless. It treats a star, a planet, or a human body with equal indifference. All are simply collections of matter to be deconstructed by the tidal teeth of the abyss. But there is a twist in this terrifying tale, a detail that adds another layer of cosmic dread to the experience. The speed and location of your destruction depend entirely on the kind of black hole you have chosen for your final descent. For a small stellar mass black hole, the collapsed corpse of a single giant star, the tidal forces at the event horizon are already astronomical. Spaghettification would happen to you before you even cross that threshold of no return, your body being ripped apart while you can still in principle see the outside universe. A swift if unimaginably painful end. But if your destination is one of the universe's true titans, a supermassive black hole, millions or billions of times the mass of our sun lurking in the heart of a galaxy, your fate is far, far stranger. These behemoths are so vast that their gravitational gradient at the event horizon is surprisingly gentle. You could in theory drift across their point of no return completely unharmed. You would feel nothing. For minutes, perhaps even hours, you would continue your fall into the darkness intact and for a terrifying moment still alive and conscious. You would be a ghost inside the machine, a traveller in a land from which no message can ever escape, witnessing firsthand the bizarre warping of space and time. But your reprieve is only temporary. The executioner has not forgotten you. As you continue your inexorable plunge deeper into the belly of the beast, the tidal forces will build slowly at first, then with the same catastrophic acceleration. Your spaghettification is not avoided, it is merely postponed, saved for a private viewing deep within the black hole's hidden sanctum. It is a death in a locked room the size of a solar system. This horrifying thought experiment forces us to confront the most profound questions we can ask. The process we've described is the destruction of your physical form, the disassembly of your matter. But what happens to the person that matter encoded? What happens to your consciousness, your memories, the unique pattern of electrical signals that constituted your mind? Does it simply vanish in that final fiery instant? Or does the bizarre physics of the black hole, where time itself is stretched to a standstill, from an outsider's perspective, preserve that information in some way we cannot yet comprehend? When you are stretched into a stream of atoms, is the story of your life somehow imprinted onto the event horizon itself, a cosmic hologram for eternity? This is not just a question of survival, it is a question that strikes at the heart of reality. Pitting Einstein's theory of relativity against the strange and ghostly laws of quantum mechanics. The 0.1 second destruction of your body is just the beginning of the mystery. It is the violent physical act that opens the door to a far deeper and more unsettling inquiry into the nature of time, information, and existence itself. To truly understand what it means to fall into a black hole, we must journey past the point of bodily annihilation. We must follow your ghost into the machine and dare to ask the ultimate question. What lies at the heart of the darkness? What if the fastest thing in the universe was not fast enough? Imagine a prison built not from steel or stone, but from the very shape of reality itself. A cage so powerful that its bars are the warped geometry of space-time, and its warden is gravity absolute and unforgiving. From this prison nothing can ever escape. Not a starship, not a planet, not a single particle of dust. Not even light, the absolute speed limit for all of creation, can break free once it has crossed the threshold. This is not science fiction. This is the chilling physical reality of a black hole, a place where our most fundamental laws of physics are pushed to their breaking point and beyond. To understand this ultimate cosmic abyss, we cannot begin with telescopes peering into the dark. Our journey must start 2 centuries ago in the mind of a quiet English rector, a man who saw the ghost of a black hole hiding within the elegant mechanics of Isaac Newton. His name was John Michell, a brilliant but reclusive natural philosopher living in an age of reason and revolution. In 1783, long before anyone had ever dreamed of bending space or slowing time, Michell engaged in a remarkable thought experiment. He lived in a Newtonian universe, a cosmos governed by a universal law of gravitation, a force that reached out across the void to pull objects toward one another. He also knew, thanks to Newton's other work in optics, that light could be conceived of as a stream of tiny particles, or corpuscles. Like any other particle, like a cannonball fired from the Earth, he reasoned that light must also be subject to gravity's relentless pull. From this simple, almost quaint set of assumptions, an astonishing conclusion emerged. Michell began to wonder about escape velocity. He knew that to escape the Earth's gravitational embrace, a cannonball must be fired at a tremendous speed, over 11 kilometers per second. If it travels any slower, it will inevitably fall back. He then asked a profound question. Could a celestial body be so massive and so compressed that its escape velocity would be greater than the speed of light itself? He meticulously calculated that a star 500 times wider than our Sun, but with the same density, would have such an immense gravitational field that its own light would be unable to climb out. The light particles fired from its surface would rise for a moment before being rained in, falling back to the star like a fountain spray. The star would become invisible to the distant universe. It would be a dark star, a star cloaked in its own gravitational shroud. For Michell, this was a fascinating but purely theoretical curiosity, a phantom born from the cold logic of Newtonian equations. He had no way of knowing that he had brushed against one of the most extreme and violent concepts in the entire cosmos. His idea, published in a letter to the Royal Society, was largely forgotten, a footnote in the history of science. Over a decade later, the brilliant French mathematician Pierre-Simon Laplace, completely unaware of Michell's work, independently arrived at the very same conclusion. He too envisioned these core obscures or dark bodies populating the heavens, forever hidden from our view. But for the scientific establishment of the 19th century, the idea was simply too bizarre, too far removed from the observable clockwork of the solar system. The wave theory of light became dominant, and the concept of light as a particle that could be pulled by gravity fell out of favour. The dark star, this gravitational ghost, faded back into the intellectual shadows, waiting. It would wait for more than a century for a new kind of physics, a new understanding of reality itself, to be born from the mind of a German patent clerk. Albert Einstein did not set out to find monsters in the dark. He was obsessed with a deep and beautiful paradox. For over 200 years, Newton's law of universal gravitation had reigned supreme. It described how a planet orbits a star with stunning precision, yet it held a secret absurdity. According to Newton, gravity was a force that acted instantaneously across any distance. If our Sun were to suddenly vanish, Newton's equations predicted that Earth would instantly fly off its orbital path into the cold darkness. But Einstein's own special theory of relativity, published in 1905, had already established a cosmic speed limit, the speed of light. Nothing, not even information, could travel faster. Gravity could not be instantaneous. Newton's elegant law, the bedrock of physics for centuries, had to be wrong, or at the very least incomplete. For 10 years, Einstein wrestled with this problem in a titanic intellectual struggle. His quest was to reimagine gravity, to discover its true nature. The breakthrough, when it came, was a complete demolition and reconstruction of our concepts of space and time. In his general theory of relativity unveiled in 1915, Einstein declared that gravity is not a force at all. It is not an invisible rope pulling you down to your chair. Gravity, he proposed, is the consequence of mass and energy warping the very fabric of the universe. He asked us to picture space and time not as a static empty stage on which the cosmic drama unfolds, but as a dynamic, flexible entity in its own right, a four-dimensional fabric he called space-time. Imagine this fabric stretching to infinity in all directions. A massive object like our Sun doesn't pull the Earth with a mysterious force. Instead, its immense mass creates a deep depression, a gentle curve in the surrounding space-time, much like a heavy bowling ball placed on a stretched rubber sheet. The Earth in its orbit is not being pulled. It is simply following the straightest possible path through that curved, distorted geometry. It is coasting along the rim of the valley created by the Sun. In Einstein's universe, planets are not prisoners of a force. They are cosmic marbles rolling along the contours of a warped reality. This was a revolution in thought so profound it shook the foundations of our worldview. It replaced the force of gravity with the shape of space, a concept as beautiful as it was bizarre. And locked within the dense labyrinthine mathematics of his new theory were equations that described how this space-time fabric could be bent, stretched and twisted. He had given humanity the rules, but he had not yet foreseen the monsters those rules would allow. The world was at war. As Einstein published his masterpiece in Berlin, a German astrophysicist named Karl Schwarzschild was serving on the Russian front calculating artillery trajectories amidst the deafening roar of combat. Despite the hellish conditions, Schwarzschild obtained a copy of Einstein's work and was immediately captivated. While Einstein himself had only managed to find approximate solutions to his own ferociously complex equations, Schwarzschild, in a feat of pure intellectual brilliance, found an exact solution. In the mud and chaos of the battlefield, he calculated the precise geometry of space-time around a single, spherical, non-rotating mass. He mailed his results to an astonished Einstein, who presented the work on his behalf to the Prussian Academy of Sciences. It was the very first confirmation that Einstein's abstract theory could yield concrete physical predictions. But Schwarzschild's solution contained something deeply unsettling. His mathematics described how space-time curves around an object like a star. As you get closer to the star, the curvature becomes more pronounced. This was expected. But the equations also held a prophecy. They predicted that if you could compress any amount of mass into a sufficiently small volume, the curvature of space-time would become infinite. The structure of reality itself would collapse inward, pinching off into a point of zero volume and infinite density. Schwarzschild had not just rediscovered Michel's dark star, he had given it a terrifying new identity forged in the language of warped space-time. He had calculated the precise boundary of this object, a critical threshold now known as the Schwarzschild radius. For an object with the mass of our Sun, this radius is a mere 3 kilometers. For the Earth, it is the size of a small marble. This boundary is not a physical surface you could touch. It is far more profound. It is a one-way door in space-time. It is the event horizon. Crossing it is not a matter of engine power or velocity. It is an inevitability written into the geometry of the universe. Inside the event horizon, the curvature of space-time is so extreme that all possible paths, every single trajectory you could possibly take lead in only one direction inward toward the center. The future itself points to the core. Imagine you are in a river paddling a canoe. Far upstream the current is gentle, and with enough effort you can paddle against it and return to the bank. But as you drift downstream, the river narrows and the current quickens. Soon you hear a roar. You've drifted too close to the edge of a colossal waterfall. At this point, the water is rushing over the precipice faster than you could ever hope to paddle. No matter which way you turn your canoe, no matter how hard you fight, you and the water you're in are going over the edge. The event horizon is that final roaring edge of the waterfall. It is the precise point where the required escape velocity equals the speed of light. But in the language of relativity, it is more accurate to say that it is the point where space-time itself is flowing inward into the black hole faster than light. Since nothing can travel faster than light through space, once you cross that threshold, escape is a geometric impossibility. You are caught in a current of collapsing reality, a current that drags you inexorably toward your fate. And what is that fate? What lies at the destination of this one-way journey? Schwarzschild's equations point to a place that defies all logic and language. They point to the singularity. The singularity is the heart of the black hole, the point where all the mass that has ever fallen in is crushed into an infinitesimally small space. Here, according to general relativity, the curvature of space-time becomes infinite. Density becomes infinite. The gravitational pull becomes infinite. It is a place where space and time as we understand them cease to exist. Our laws of physics, the very tools we use to describe the universe, break down completely. The singularity is not a place in the universe. It is an end to the universe. It is a cosmic dead end, a wall at the edge of reality. For decades, many physicists, including Einstein himself, refused to believe that such an object could actually form in nature. They saw Schwarzschild's singularity as a mere mathematical anomaly, a flaw in the equations that would be resolved by a more complete theory. They couldn't accept that the cosmos would permit such a monstrous physics-breaking object to exist. But the universe, we have learned, is under no obligation to conform to our sense of reason or comfort. We now know that black holes are real. We have seen the shadows they cast against glowing clouds of gas. We have watched stars orbit these points of utter blackness, their paths dictated by the unseen gargantuan masses within. We have even detected the faint gravitational ripples, the echoes in space-time from the violent collisions of two black holes in the distant universe. The ghosts of Michel and Laplace have become terrifyingly real, scattered throughout the cosmos by the millions. We stand on the precipice of understanding, staring into an abyss from which no information can return. We have established the existence of this ultimate prison. We have mapped its one-way gate, the event horizon, and we have glimpsed the mathematical horror of the singularity that lies within. We know that the gravity near these objects is the most powerful force in the cosmos. This leaves us with the most intimate and terrifying question of all. We understand the destination, but what about the journey? What would actually happen to you if you were to take that fall? We often imagine being crushed by the immense gravity, flattened into oblivion. But the truth is far stranger, more specific, and infinitely more violent. Before you ever reach the singularity, before you even cross the event horizon of a smaller black hole, your body will be subjected to a force so perverse and so powerful that it will execute you in the most brutal way imaginable. It is not gravity itself that will kill you. It is the difference in gravity. What are these cosmic forces of separation, these gravitational tides so extreme they can stretch and tear the very atoms of your being across the fabric of space? To find the answer, we must now move beyond the elegant geometry of space-time and into the raw physical mechanics of your final, terrifying moments. We must understand the force that will shred you into a stream of fundamental particles in less than the blink of an eye. And so you fall. You're captured a mote of dust in an infinite cosmic river, pulled by a current of space-time so powerful that light itself cannot escape its flow. In the previous chapter of our journey, we confronted the raw, absolute nature of this gravitational pull, a force that bends worlds and devours stars. We imagined it as a simple monolithic force, a cosmic drain pulling everything toward a single inescapable point. But to truly comprehend your fate, to witness the horrifying mechanics of your final moments, we must now discard that elementary image. The truth of gravity, especially the gravity reigning here at the edge of oblivion, is far more insidious, more intimate, and infinitely more violent. Its true weapon isn't the uniform pull that draws you in. It's the difference in that pull from one inch to the next. Its killing power lies not in its strength, but in its gradient. To understand this, we must first return home to our own gentle world and look to the patient rhythm of the oceans. Twice a day, coastlines around the globe watch the sea draw a deep breath and then exhale. This is the tide, a phenomenon so familiar we rarely consider the colossal forces at play. We are taught that the moon's gravity pulls on the Earth, creating this aquatic pulse. But that explanation is deceptively simple, missing the crucial detail. The moon does not pull on the Earth as a single solid object. It pulls on every single particle of our planet, every mountain, every ocean droplet, every atom in your body. And critically, it pulls more strongly on the parts of the Earth that are closer to it. The water on the side of the Earth facing the moon is pulled with slightly more force than the solid core of the planet beneath it. This differential pull causes the ocean to bulge outward, creating a high tide. But what about the other side of the planet? The side facing away from the moon. There the ocean also bulges. Why? Because here the moon's gravity is at its weakest. It pulls on the solid Earth more strongly than it pulls on the distant water, effectively leaving that water behind. The result is a second opposing high tide. Our planet is constantly gently being stretched along this Earth-Moon axis. It is a planetary scale massage, a subtle elongation orchestrated by a whisper of gravity from 250,000 miles away. These are tidal forces. On Earth, they are benign, a source of poetry and power. They are the gentle ghost of a far more terrifying cosmic principle. For what the moon does delicately to our oceans, a black hole does with unimaginable brutality to the very fabric of matter. The principle is identical. The scale is apocalyptic. Let us leave the familiar shores of Earth and travel to a place where this principle is written in fire and stone, Jupiter's innermost Galilean moon, Io. From a distance, Io is a marble jewel of sulphurous yellows, reds and blacks, but this beauty is born of pure torment. Io is the most volcanically active body in our entire solar system. Its surface is a tortured canvas of colossal volcanic plumes, vast plains of molten rock and mountains heaved miles into its thin atmosphere. This is not the familiar geothermal heat of a planet's core driving a few isolated volcanoes. This is the entire world being continuously broken and melted from the inside out. Io is trapped in a gravitational tug-of-war between the colossal mass of Jupiter and the rhythmic pulls of its neighbouring moons, Europa and Ganymede. As it orbits, it is squeezed and stretched by Jupiter's immense gravitational field like a cosmic stress ball. The side of Io facing Jupiter is pulled with immensely more force than the side facing away. The difference in that pull across Io's 2,000-mile diameter is so extreme that its solid crust rises and falls by over 300 feet with every orbit. Imagine the entire landscape mountains and all heaving up and down by the height of a skyscraper every 42 hours. This relentless flexing generates an incredible amount of friction, deep within the moon's interior, melting its mantle into a global ocean of magma. The spectacular volcanic eruptions we see are just the surface expression of this deep, agonizing torment. Io is a world being torn apart by tidal forces. It is a visceral system-scale demonstration of what happens when the gentle stretching we see in our oceans is amplified by a true gravitational monster. It is a warning, a preview of the physics that now governs your own descent. Because where you're going, the forces that disfigure a world are compressed to the scale of a single human body. To grasp the terrifying intimacy of this process, let's bring the scale down to something human. Imagine you and a fellow astronaut are on a spacewalk tethered together, and you have both through some catastrophic error begun to fall toward a small stellar mass black hole. You are falling feet first. At first, the sensation is one of weightlessness, the classic illusion of freefall. You feel nothing, but the laws of physics are already at work signing your death warrant. The black hole's gravity, governed by the inverse square law, intensifies exponentially with proximity. Your feet being just 6 feet closer to the singularity than your head are experiencing a measurably stronger gravitational pull. At a great distance, this difference is trivial, smaller than the variance you'd feel standing on a flight of stairs on Earth. But the tidal force, this differential force, doesn't follow the inverse square law. It obeys a far more savage rule, the inverse cube law. This is a critical distinction, and it is the secret to the black hole's destructive power. As you halve the distance to the singularity, the overall gravitational pull on your centre of mass quadruples. But the tidal force, the stretching force between your head and your feet, doesn't just quadruple. It increases by a factor of 8. Every metre you fall closer, the disparity in the pull grows with breathtaking, catastrophic speed. Soon you would feel it, not as a pull, but as a tension. It would start as a subtle, unfamiliar ache in your joints, as if you'd been hanging from a pull-up bar for too long. The tether connecting you to your fellow astronaut would grow taut. The person falling slightly ahead of you, closer to the black hole, would begin to accelerate away, the tether straining under a load it was never designed to bear. This is the gravitational differential engine at work. It is not pulling you together. It is a force of separation. The atoms in your boots are being pulled away from the atoms in your shins. The bones in your legs are being pulled from their sockets in your pelvis. Your spine, a column of individual vertebrae, is being subjected to an impossible tension, each segment pulled more forcefully than the one above it. You are being placed on a cosmic rack designed by the universe itself, and the force is not just vertical. As you're stretched, another aspect of the tidal force comes into play. While your head and feet are pulled apart along the line of your fall, the rest of your body is being squeezed from the sides. Gravity is pulling every particle of your being toward the single, infinitesimal point of the singularity. Imagine lines radiating from that point out toward you. The lines hitting your left shoulder and your right shoulder are not perfectly parallel. They are converging. This convergence applies a colossal compressive force, squeezing your body from all sides, crushing your shoulders inward, flattening your torso. You're being simultaneously stretched and compressed, pulled longer and squeezed thinner. The process has a name, a term coined by astrophysicists, that is both clinically descriptive and viscerally horrifying: spaghettification. Before you ever reach the event horizon of this stellar mass black hole, long before the point of no return where light itself is trapped, these tidal forces would become insurmountable. The ache would become an unbearable strain, then a sharp, tearing agony. The delicate structures of your body, evolved for the gentle, uniform gravity of a small planet, are simply no match for this focused violence. The human frame can withstand tremendous compressive forces. We can survive astonishing impacts, but our tensile strength, our ability to resist being pulled apart, is pathetically weak. Your body would begin to fail at the molecular level. Your skin, your muscles, your organs, your very bones would be stretched past their breaking point. First, your joints would dislocate. Your limbs pulled with more force than your torso would be torn from their sockets. The integrity of your skeleton would fail, your spine elongating and then snapping. Your circulatory system, under the immense strain, would rupture. But the process wouldn't stop there. The tidal forces continue to increase their power, growing by the inverse cube of the distance. The very tissues of your body, now unmoored from the skeleton, would be drawn out into long, thin filaments. Even the cells themselves would be warped, their membranes stretched until they burst. In the final imperceptible fraction of a second, the bonds holding molecules together would be overwhelmed. The fundamental forces of chemistry would surrender to the raw power of gravity. Your body would cease to be a biological entity. It would be rendered into a thin, glowing stream of constituent atoms, a trail of incandescent plasma, a few atoms wide and perhaps miles long, accelerating toward the event horizon. All of this, from the first subtle ache to your atomic disintegration, would happen in the blink of an eye. For a stellar mass black hole, your destruction is not an event that takes place inside the abyss. It is the brutal toll you must pay just to knock on its door. The event horizon is a finish line you would never reach in a recognizable form. But what if the black hole were different? What if it were not a mere stellar mass object, but a supermassive behemoth? Millions or even billions of times the mass of our sun, lurking in the heart of a galaxy. Here the story changes in a profound and terrifying way. The sheer size of a supermassive black hole alters the geometry of its gravitational field. Because its event horizon is so enormous, stretching for millions of miles, the curvature of space-time at its edge is much, much gentler. The inverse cube law still applies, but you're so far from the central singularity, even as you approach the horizon, that the tidal forces are for a time survivable. The gradient of gravity is spread out over a much larger distance. For a supermassive black hole like Sagittarius A, the monster at the centre of our own Milky Way, the stretching force at the event horizon would be less than that which you feel on Earth. You could cross the boundary, the point of no return, completely intact. You would sail past the cosmic veil, the last point from which a message could ever escape, feeling nothing more than the serene sense of weightless freefall. You would be alive and for a few moments perhaps even conscious inside the black hole. The universe outside would be gone from your view, its light unable to follow you across the threshold. You would be utterly and completely alone, cut off from all of space-time. But your reprieve is temporary. The singularity still awaits. Inside the event horizon, the journey continues, and the tidal forces you so gently bypassed now begin to build with a ferocity that dwarfs anything a lesser black hole could produce. The fate of spaghettification is not avoided. It is merely postponed, reserved for the final act of your journey within the abyss itself. Whether you are torn apart in a flash of agony outside a small black hole, or granted a few moments of eerie tranquility before your annihilation inside a large one, the culprit is the same. It is not the simple brute force pull of gravity that seals your doom. It is this far more elegant, far more terrifying principle, the relentless, irrefutable fact that in the domain of a black hole, no 2 points in space experience the same reality. It is the cosmic shear, the differential pull across the infinitesimal space separating one atom from its neighbour. This is the force that unmakes matter the gravitational scalpel that will dissect you with inhuman precision, and as you continue your fall, this is the force that is now beginning to awaken to take notice of your presence, to measure the distance from your head to your feet, and to prepare its inexorable final judgment. The quiet hum of the cosmos has vanished, replaced now by a low resonant thrum that you feel more than you hear. It's a vibration in your very bones, a signal that the abstract laws of physics we discussed are becoming a terrifying, tangible reality. The gentle, inexorable pull we spoke of is no longer so gentle. It is becoming insistent, a preference. The black hole is no longer just pulling you in. It is beginning to dissect you from a distance, using gravity as its scalpel. You feel an unnerving sensation, a faint but persistent tugging at the edges of your body. It is not the feeling of acceleration of being dragged uniformly forward. This is something far more sinister. Imagine for a moment that every single atom in your being has a tiny invisible cord attached to it, each one leading directly to the singularity. Now imagine the cords attached to your feet are being pulled with immensely more force than the ones attached to your head. This is the dawn of the tidal force, the universe's most extreme stretching rack. The difference in gravity across the mere 2 meters of your height, a value that was infinitesimal just moments ago, is now growing exponentially with every kilometer you fall. It is a silent mathematical predator, and its grip is tightening. At first it might feel like a strange pins and needles sensation, a phantom limb being pulled, but soon that tingling sensation becomes a deep wrenching ache in your joints. Your spine, a marvel of evolutionary engineering designed to withstand the crushing gravity of a planet, feels a new kind of stress, not compression, but tension. A relentless longitudinal pull that seeks to separate each vertebra from its neighbour. You're on a gravitational gradient so steep it could be measured across your own form. Your body, which has only ever known the uniform gravity of Earth, is now a complex instrument measuring the terrifying curvature of space-time. Every cell is screaming a different number. The pull on your ankles is measurably painfully stronger than the pull on your knees. The force on your heart is significantly less than the force on your pelvis. This differential is the key. It is the mechanism of your undoing. Your entire existence has been governed by forces that hold you together. The powerful electromagnetic bonds between your molecules, the cohesive strength of your tissues, the structural integrity of your skeleton. These are the forces of life, the glue that maintains the intricate architecture of a human being against the chaos of the universe. For your entire life, they have been more than enough. They have held you together through impacts, illnesses, and the simple, constant pressure of Earth's atmosphere. But you are now entering a realm where the rules have been rewritten by a monster. The black hole does not care about your biology. It does not recognize the chemical covenants that define you. It pits the most powerful force in the cosmos, gravity, against the delicate bonds of your own matter. This is a battle you were never meant to win. We can even calculate the breaking point. Scientists call it the Roche limit, the distance at which the tidal forces of a celestial body will rip apart another object held together by its own gravity. A moon that wanders too close to its planet is a classic example, torn asunder to form a beautiful tragic ring system. But you are not a moon. You are not held together by your own feeble self-gravity. Your form is maintained by the far more robust strength of your biological materials. Your bones have a specific tensile strength, the amount of stretching they can endure before they snap. Your skin, your muscles, your tendons, they all have a measurable elasticity, a point beyond which they will tear. We can therefore define a new kind of boundary, a grim perimeter in space, your personal Roche limit. It is the line you're now crossing, the invisible threshold where the black hole's differential pull becomes greater than the molecular forces holding your body intact. The transition is not gentle. It is a catastrophic, instantaneous failure. One moment you're a human being contorted in agony. The next you're a process, a demonstration of physics. The first thing to fail would likely be your largest, most rigid structures. Your femur, one of the strongest bones in your body, capable of withstanding thousands of pounds of compressive force, is now subjected to a tension it was never designed for. It does not bend, it shatters. The sound, were there any air to carry it, would be a sharp percussive crack. But there is only silence and the horrifying tactile sensation of your own body coming apart. Your spine, already stretched to an impossible length, disarticulates. The vertebrae, once a beautifully stacked column, are pulled away from each other, severing the spinal cord within. All neural communication between your brain and the lower half of your body ceases. You would be mercifully perhaps numb from the waist down, though the agony in your torso and head would be all-consuming. Simultaneously, another equally violent process is underway. While the tidal force is stretching you along the line towards the black hole, it is also compressing you from the sides. The same gravitational differential that pulls your head and feet apart also pulls every particle of your being toward the center line of your body. Imagine being in a room where the walls are closing in at the same moment the ceiling and floor are moving apart. It is a cosmic vice grip. Your shoulders are crushed inward, your ribs snapping and folding as your chest cavity collapses. The pressure becomes so immense that the very fluids in your cells are squeezed out. Your body, a vessel of water and complex chemistry, is being wrung out by the fabric of space-time itself. You are being stretched and squeezed into a new horrifying shape. The process accelerates with blinding speed. The failure of your skeletal system triggers a cascade. With your bones broken and pulled apart, your muscles and ligaments, no longer anchored, tear like wet paper. Your skin, stretched beyond its limits of elasticity, rips open. Your internal organs, no longer contained by the abdominal wall or protected by the rib cage, are pulled from your body and elongated into grotesque ribbons of tissue. It is not an explosion, a chaotic spray of biological matter into the void. It is a terrifyingly orderly deconstruction. Every piece of you is meticulously and violently drawn out into a long, thin strand following the gravitational lines of force directly toward the singularity. You are no longer a complex three-dimensional being. You are becoming a one-dimensional line pointed at the heart of the abyss, and the black hole is not finished with you. Your destruction transcends the merely biological. The tidal forces that dismantled your body continue their work on a smaller, more fundamental scale. The long chains of proteins and polymers that formed your tissues are now subjected to the same differential pull. The chemical bonds holding those molecules together, the very foundation of your organic chemistry, are the next to break. The carbon, hydrogen, oxygen, and nitrogen that composed you are stripped from their complex arrangements. Hemoglobin, DNA, adenosine, triphosphate. The intricate molecules of life are unraveled, their atoms pulled apart by the irresistible gravitational shear. You have ceased to be biology. You're now just chemistry, a flowing stream of dissociated elements. Even this is a temporary state. The tidal forces continue to escalate, reaching down to the next level of reality. They grasp the atoms themselves. An atom is a durable thing, a nucleus of protons and neutrons orbited by a cloud of electrons, all bound by the powerful electromagnetic force. For billions of years, the atoms that make up your body have remained stable, participating in countless chemical reactions, forming stars, planets, and eventually you. But here on the doorstep of infinity, even the atom finds its master. The tidal force across the infinitesimal diameter of a single atom becomes significant. The gravitational pull on the side of the atom closer to the black hole is stronger than the pull on the far side. The atom itself begins to stretch. The electron cloud is warped, distorted into an ovoid shape. The nucleus is pulled one way, the electrons another. The electromagnetic force, the second strongest force in nature, finally gives way. The electrons are stripped from their nuclei. What was once a human being is now a stream of plasma. You are a thin, incandescent filament of protons, neutrons, and electrons glowing with the heat of your own disintegration. This ribbon of matter, a spectral ghost of your former self continues to accelerate toward the event horizon. Astronomers have a name for this. They call it a tidal disruption event. We have seen this happen from unfathomable distances when an unlucky star wanders too close to a supermassive black hole. We watch through our telescopes as the star is pulled into a long, brilliant noodle of gas before being consumed. What you're experiencing is the same cosmic phenomenon scaled down to the intimate, horrifying level of a single human body. You've become your own personal constellation of death, a momentary streak of light against the ultimate darkness. Your constituent particles, once organised into a thinking, feeling being, are now just fuel and offering to the singularity. This entire cataclysm, this complete and utter annihilation of your physical form from skeleton to subatomic particle, unfolds with a speed that is almost impossible to comprehend. The title of our journey is not hyperbole, it is a horrifying calculation. In the ferociously steep gravitational well of a stellar mass black hole, the region where the tidal forces escalate from merely painful to utterly unsurvivable is incredibly narrow. You're falling through this lethal zone at a significant fraction of the speed of light. Let's pause the simulation for a final, terrible moment of clarity. The distance from the point where your bones begin to break to the point where your atoms are ionized is traversed in an almost immeasurably short span of time. We can calculate it. The time it takes for the tidal force to exceed the tensile strength of your body and then overwhelm the electromagnetic force holding your atoms together, all while you fall at relativistic speeds. The result is approximately 1/10 of a second, 0.1 seconds, less time than a single human heartbeat, faster than a conscious thought can form. One moment you are a being of immense complexity and history, and in the next flicker of existence you are an ionized stream of matter plunging into darkness. There is no time to scream, there is no time to process the unimaginable pain or the existential horror of your own unmaking. The universe does not grant you the mercy of a final moment. Your end is not a narrative. It is a physical event as swift and impersonal as a lightning strike. Your entire life, your thoughts, your memories, your consciousness, all embodied in a physical structure that is erased from the universe in a flash of gravitational violence. And the most profound, the most unsettling part of this entire sequence, it has all happened outside the black hole. You have not yet crossed the event horizon. This complete destruction, this reduction of a human being to a plasma stream is merely the prelude. It is the terrible price of admission. You have been killed by the journey, not the destination. The stream of particles that was once you continues its inexorable fall, a glowing testament to the power of gravity. It is this stream, this ghost of matter, that will now cross the final boundary, the one from which not even light can escape. The question that remains suspended in the silent void is what happens next. What becomes of this fundamental information, this atomic echo of a life when it finally slips beyond the veil and falls forever into the singularity? And so, the deed is done. The magnificent, intricate vessel that was a human body, a walking, thinking miracle of chemistry and electricity, is gone. It has been unwritten from the book of life, its story violently erased by the savage grammar of gravity. What remains is not a corpse, but a legacy. A fleeting, luminous epitaph written in the language of fundamental physics. You are now a river of incandescent plasma, a stream of constituent atoms stretched into a miles-long filament, arcing downwards at an impossible speed. This celestial contrail, this final fleeting monument to a life, glows with the furious energy of its own annihilation. It is a searing thread of light, pulled thin by the relentless loom of space-time plunging toward the blackness that commanded its creation. For a moment, this stream is all that is left of you, a fiery testament hurtling into the void. But here at the very precipice of oblivion, a final bewildering schism occurs. Reality itself, which we so confidently assume to be a single shared experience, bifurcates. It splits into two irreconcilable truths, two stories being told about your final moments. One story is told by the universe you left behind. The other is told by the atoms that carry the last vestiges of your being, and they could not be more different. Let us imagine a friend, a steadfast companion stationed at a safe distance, watching your descent through the lens of an impossibly powerful telescope. For them, for the entirety of the observable cosmos, your fall does not accelerate into a swift, merciful end. Instead, something profoundly strange begins to unfold. As your atomic stream approaches that sharp, dark edge in space, the event horizon, it appears to slow. Not as if it were hitting the brakes, but as if it had plunged into a pool of cosmic molasses, a gravitational quicksand that thickens with every inch of descent. This is the grand illusion of general relativity, a cosmic magic trick performed with the very fabric of existence. Gravity in its most extreme form does not just bend space, it warps time itself. Close to the black hole, the river of time flows sluggishly, while for your distant friend it continues its inexorable rush forward. Every tick of their clock corresponds to a smaller and smaller fraction of a second for you. From their perspective, your final desperate millimetre of progress toward the horizon takes a year. The next micron takes a century, the next nanometer an eternity. You are caught in a gravitational stasis, trapped in the amber of distorted space-time. Simultaneously, another equally bizarre transformation is taking place. The light from your superheated glowing remains must fight its way out of the black hole's immense gravitational well to reach your friend's telescope. This is an uphill battle against the curvature of the universe itself. With every photon that escapes, a price is paid. Energy is stolen from the light, stretching its wavelength, shifting its colour. This is gravitational redshift, the universe's way of sapping the strength from a dying message. The brilliant blues and searing whites of your plasma stream signals of immense heat and violence begin to dim and redden. Through that distant lens, your fiery trail shifts from a celestial blowtorch to a desperate burning orange. Then, over agonizingly long periods, it cools further, becoming a blood-deep crimson, the colour of a fading ember. The light becomes weaker, the signal more tenuous. Your friend watches as your spectral ghost, once a brilliant streak against the abyss, is stretched and drained of its energy, fading like a photograph left in the sun. After what might be thousands of years from their perspective, the last visible photons will struggle free, arriving as faint infrared whispers. Then nothing. Your atoms, your very essence, will appear to be frozen forever at the edge of the event horizon, a final, silent two-dimensional painting plastered against the abyss. You will become a permanent phantasmal afterimage, a ghostly sentinel at the gates of hell, never quite falling in, never able to escape. A perpetual static monument to the place where the laws of physics break down. For the rest of time, from the viewpoint of every star and every galaxy, you are a part of the horizon, a frozen tableau of a journey's end. But that is their story. It is not yours. For you, for the disassembled consciousness now encoded in this stream of fundamental particles, there is no slowing down. There is no gentle fade to black. There is only the fall. You do not feel time dilating. Your internal clock, whether it is the decay of a radioactive isotope in your atoms, or the vibration of a quark, ticks on as it always has. 1 second for you is still 1 second for you. It is the universe outside that has gone mad, its clock accelerating to an infinite speed. As you plunge downwards, the entire future history of the cosmos flashes past in the light that falls in with you. You witness the birth and death of stars in the blink of an eye. Galaxies evolve, collide and decay in the time it takes to draw a breath you no longer have. The universe ages, cools and dies in a final brilliant flash of blue-shifted light that funnels into the abyss behind you. The event horizon, that boundary that seems so absolute to an outsider, is for you a place of no particular significance. It is not a wall, it is not a membrane. There is no signpost that reads, "You are now entering the black hole." You cross it. You simply fall through the geometric line that separates the world of maybe from the world of must. One moment escape was in principle possible. The next moment it is not, and you feel absolutely nothing to mark the transition. The fall continues unabated, relentless. The downward path is all there is. The plunge into darkness is swift, brutal, and utterly final. The universe saw you freeze, but you experienced an unbroken, terrifying acceleration into the heart of the maelstrom. Two realities born from a single event, forever unable to reconcile. One frozen in time, the other consumed by it. And here in this grand cosmic paradox lies yet another layer of complexity, another twist in the journey that depends entirely on the nature of the beast you have encountered. For not all black holes are created equal. The story we have just told of a violent external shredding followed by a fall into the abyss is the story of a stellar mass black hole. These are the common piranhas of the cosmic ocean. Born from the collapse of a single massive star, they are relatively small, perhaps only a few dozen miles across. Their diminutive size concentrates their gravitational gradient into a ferociously steep curve. For these celestial monsters, the tidal forces, the stretching and squeezing we call spaghettification, become lethal long before you ever reach the event horizon. They are cosmic butchers that tear you apart out in the open in full view of the universe before swallowing your constituent pieces. The destruction is the prelude to the fall. You are disassembled first, and only then does your atomic stream cross that final threshold, fading from outside view as it plunges toward the singularity within. This is the fate that awaits any traveller unlucky enough to wander too close to these ubiquitous violent remnants of dead stars. But there is another kind of monster in the dark, vastly larger, ancient, and in some ways far more insidious. These are the supermassive black holes, the silent gravitational anchors around which entire galaxies spin. They are not born from a single star, but have grown over billions of years, devouring millions, even billions of suns, gas clouds, and other black holes. They are incomprehensible leviathans with event horizons that can be larger than our entire solar system, and it is here in the face of such scale that the nature of your fall changes completely. A supermassive black hole is so immense, so titanically vast, that the curvature of space-time at its edge is surprisingly gentle. The gravitational gradient, the difference in pull between your head and your feet, is almost negligible as you approach the event horizon. Its tidal forces are like the slow, gentle swells of a deep ocean, not the crashing, violent waves of a shallow shore. This leads to a possibility so profound, so utterly terrifying, that it stands as one of the most chilling concepts in all of science. If you fall into a supermassive black hole, you can cross the event horizon completely intact. There is no spaghettification, not yet. Imagine it. You're an astronaut adrift, your trajectory sealed. You float toward the great darkness, a sphere of perfect blackness that swallows the stars behind it. You feel no pain. You feel no stretching. You feel only the gentle, persistent tug of gravity, a silent and inexorable pull forward. Your ship's instruments might register the bizarre warping of space-time, but your body gives you no such warning. You look out of your viewport. The light from the universe behind you begins to warp and distort the starfield, compressing into a smaller and smaller window, as if you are looking out the back of a speeding train. But you are whole. You are still you. And then you cross. You pass through the event horizon, that one-way membrane in the fabric of reality. The window to the universe behind you snaps shut. All light, all information, all possibility of escape is now gone. You're inside, a ghost in the machine. A message in a bottle thrown into an ocean with no shores. From the perspective of your distant friend, the story remains the same. Your ship appears to slow redshift and freeze at the horizon for all eternity. But for you, the reality is a new and unique kind of horror. You're alive and conscious in a place from which you can never leave, and from which no word of your fate can ever be sent. You're sealed within a private universe of falling, a bubble of space-time disconnected from everything that ever was or will be. The laws of physics inside this bubble have one single, terrifying rule. All paths, all possible futures lead in only one direction. Down. The singularity, the point of infinite density at the centre, is no longer a place in space. It has become an event in time. It is your future. Just as you cannot avoid next Tuesday on Earth, you cannot avoid hitting the singularity inside a black hole. It is the end of time itself, and it is coming for you. And the spaghettification, that brutal body-shredding force we thought you had escaped, it has not been avoided. It has merely been postponed. As you continue your silent fall through the internal warped dimension of the black hole, the gravitational gradients will begin to steepen once more. The gentle pull will become a firm grip, then a violent wrench. Deep within the hidden interior, far from the prying eyes of any possible observer, the tidal forces will finally find you. The stretching will begin. The universe's most violent act will be carried out in the dark, a final secret execution. You will be unmade just as you would have been in a stellar mass black hole, but you will have been granted the chilling privilege of being conscious and whole as you pass the point of no return. You were given a moment of quiet passage into the prison, a brief deceptive calm before the inevitable sentence was carried out. So the downward path is not a single story, but a choice of fates. Do you meet your end violently torn asunder for the universe to see before your remnants are swallowed, or do you slip quietly behind the curtain hole and aware only to face that same dismemberment alone in the absolute inescapable privacy of eternity's prison? Either way, your constituent parts are now inside, disconnected from the cosmos. You have become pure information trapped on a collision course with the ultimate unknown, a place where our physics, our language and our imagination finally and completely fail, a place we can only call the singularity. The light is gone, all of it, not just dimmed or redshifted into oblivion, but fundamentally absent. The very concept of direction has been annihilated, folded into a single inescapable vector pointing forward. There is no longer a you and a destination, there is only the fall. Every particle of your being, every atom that once looked up at the stars is now a slave to a gradient of space-time so steep it has become a precipice with no bottom. The tidal forces you endured, that terrible stretching, was merely the overture. Now the symphony of destruction plays its final silent chord, pulling you into the heart of the enigma. Ahead of you lies not a place, but a verdict. An end point of space-time itself, a concept our mathematics calls the singularity. This is the destination you can never reach, yet cannot possibly avoid. It is a point that is not a point, a moment that is the end of all moments. To even speak of it is to use a language of ghosts. General relativity, Einstein's magnificent tapestry of gravity, space and time, which has guided us flawlessly across the cosmos, simply stops here. It offers up an answer of infinity and falls silent like a prophet struck dumb before their own god. Infinite density, infinite curvature of space-time. These are not descriptions of a physical object. They are the universe's error message, a signpost pointing to a realm where our most profound laws are null and void. Imagine all the mass of a star, or millions of stars, or even billions crushed. Not just into a small volume, but into a volume of zero. It is a mathematical impossibility that exists a tear in the very fabric of reality where the loom itself is broken. Here the distinction between space and time dissolves completely. The future is not a direction you travel in. It is a physical location you are being dragged towards. It is the crunch, the ultimate final and absolute end. And in that end we confront the greatest crime in the cosmos. For everything you are, every memory, every unique arrangement of atoms that constituted your life is information. Physics at its quantum core has a sacred, unbreakable law. Information can never be destroyed. It can be scrambled like burning a book. The letters turn to ash and smoke, but in principle, if you could track every single particle, every photon of heat, you could reconstruct the original text. The universe, we believe, never truly forgets. It is a perfect record keeper. Yet the black hole presents us with a paradox so profound, it has haunted physicists for half a century. As you are compressed into the singularity, what happens to the information that is uniquely you? General relativity provides a chillingly simple answer: it is gone, annihilated, wiped from the cosmic ledger forever. The library of the universe has just had a book irrevocably burned its contents, lost to eternity. This is the black hole information paradox. It represents a fundamental schism in our understanding of the universe, a violent clash between our two great pillars of physics. On one side stands Einstein's relativity governing the grand tapestry of the cosmos, which insists the information is locked away and ultimately destroyed inside the singularity. On the other stands quantum mechanics, the strange and powerful rules of the subatomic world, which declares with absolute certainty that the total information of a closed system must be conserved. They cannot both be right. For decades this contradiction festered at the heart of physics. Then a breakthrough came from an unexpected quarter. Stephen Hawking, contemplating the quantum world at the edge of the event horizon, realized that black holes are not perfectly black. They should glow. he discovered that due to quantum fluctuations in the vacuum of space, pairs of virtual particles are constantly popping into and out of existence. When this happens at the very lip of the event horizon, it's possible for one particle to fall in while its partner escapes. The escaping particle becomes real, stealing a tiny fraction of the black hole's mass energy to do so. Over unimaginable timescales, trillions upon trillions of years and more, this steady leak of what we now call Hawking radiation causes the black hole to evaporate. It slowly shrinks, losing mass, until in a final brilliant flash of energy, it disappears completely. And here the paradox returns with a vengeance. If the black hole evaporates, and the information that fell inside is truly gone, then the universe has committed its ultimate crime. It has forgotten something. The law of quantum mechanics has been violated. Hawking himself initially believed the information was truly lost, a concession that shook the foundations of science. If information can be lost in a black hole, perhaps it can be lost elsewhere too. The predictable clockwork universe we thought we understood might be fundamentally unpredictable, with reality itself flickering in and out of existence. But the quantum physicists refused to yield. They argued the information must get out. Perhaps it is subtly encoded in the escaping Hawking radiation. Imagine your essence, your memories, your very being not destroyed, but shredded and imprinted on this faint, chaotic thermal glow. Each escaping particle would carry a tiny, almost imperceptible correlation to the particles that fell in before it. Reconstructing you from this cosmic static would be infinitely harder than reassembling a book from smoke and ash, but according to quantum theory it must be possible. The universe, they insisted, does not cheat. This fierce debate has led us to an even more terrifying and bizarre possibility, a potential resolution known as the firewall paradox. The argument is subtle, but its implications are violent. To preserve the laws of quantum mechanics, a delicate link must be maintained between the escaping Hawking radiation and the interior of the black hole. This link is based on a strange quantum property called entanglement, a connection between particles that persists no matter how far apart they are. But there's a problem. Quantum mechanics also dictates that a particle can only be fully entangled with one other partner at a time, a rule known as monogamy of entanglement. The escaping radiation particle needs to be entangled with all the radiation that came before it to carry out the information, but it also needs to be entangled with its twin that fell into the black hole. It cannot do both. The universe is forced to make a choice. To solve this paradox, some physicists proposed a radical, terrifying solution. Perhaps the moment a particle crosses the event horizon, the violent needs of quantum mechanics force the entanglement with its infalling partner to be catastrophically severed. Breaking this quantum bond would not be a gentle process. It would release an enormous amount of energy. The consequence would be a shell of superheated high-energy particles erupting into existence precisely at the event horizon. A wall of fire, a quantum tripwire incinerating anything that attempts to cross. In this scenario, your journey would have ended far earlier than you ever imagined. You would never reach the singularity. You wouldn't even make it inside the black hole. The instant you touch the horizon, you would be vaporized by a curtain of pure energy, your information instantly thermalized and ready to be radiated back out into the cosmos. The calm, mathematically pure event horizon we described earlier would be a lie. It would instead be the most violent boundary in the universe, a celestial blowtorch guarding the entrance to infinity. This idea is profoundly unsettling, as it violates another cornerstone of physics, Einstein's equivalence principle, the very idea that falling freely is indistinguishable from floating in empty space. An astronaut crossing the horizon should by all rights feel nothing special. A firewall would mean they feel everything all at once in a final agonizing blaze. We are left with a trilemma, a choice between three impossible options. Either information is lost violating quantum mechanics, or the equivalence principle fails and a firewall exists violating general relativity. Or there is some other even stranger physics at play that we haven't even begun to comprehend. The truth is, we are trying to read a message written in a language we do not speak. The singularity is where gravity, the force of the macrocosm, becomes so intense that it crushes matter down to the scale of the microcosm, the realm of quantum mechanics. To understand what happens here, we need a dictionary that can translate between these two languages. We need a theory of quantum gravity. This is the holy grail of modern physics, a single framework that can describe the universe at all scales, from the spin of an electron to the collision of galaxies. Theories like string theory propose that at the fundamental level, particles are not points, but tiny vibrating strings, and the singularity might be a chaotic, ultra-dense tangle of these strings. Other ideas, like loop quantum gravity, suggest that space-time itself is made of discrete, indivisible chunks, and the singularity is where you can go no further because you have reached the fundamental atom of space and time. These ideas are at the very frontier of human knowledge, magnificent mathematical structures built to peer into an abyss we can never directly observe. They tell us that the singularity might not be an endpoint of infinite density, but a transition point. Perhaps it is not a dead end, but a gateway. Could the matter and information crushed into this point rebound, giving birth to a new universe inside the black hole? Is it possible that our own universe began from just such a singularity, the remnant of a star that collapsed in some greater older cosmos? The black hole then would not be a tomb but a cosmic womb, a place where universes are born. Or perhaps the singularity is something even stranger, a place where time doesn't just stop but loops back on itself, or a point where our three spatial dimensions connect to others, a true portal in the fabric of reality. We stand at the edge of this ultimate question, armed with equations that break and theories that tremble. What is the final fate of the matter that dares this journey? Is it obliterated, its story erased from the cosmic narrative forever? Is it incinerated at the edge, its information violently recycled back into the universe? Or is it transformed, planted like a seed in the soil of a new creation, its complex information blossoming into a new reality with its own stars, its own galaxies, its own life? The singularity holds the answer. It is the point where our physics ends, but where the universe's story may just be beginning again. It is the ultimate boundary not just of space and time, but of our own understanding. We have fallen into the question mark at the center of everything, and the silence that greets us is not empty. It is filled with the weight of all the possibilities we have yet to imagine. The final truth about what lies in the heart of a black hole may not just rewrite our understanding of gravity, it may force us to redefine what we mean by space, by time, and by reality itself. And so here at the precipice of infinity, our journey reaches its inevitable, unknowable end. You have crossed the final threshold, a traveller dissolved into the very grammar of the universe, your constituent atoms now part of a mystery that transcends space and time as we comprehend them. The singularity is not a destination in any conventional sense. It is a full stop at the end of reality's sentence, a place where the laws of physics, our trusted guides through the cosmos, finally fall silent, their voices lost in an impossible roar of infinite density. This is not just the end of your fall. It is the end of the path itself, a point beyond which the map is not merely blank, but utterly inconceivable, a concept torn from the fabric of logic. We began this descent together, propelled by a curiosity as powerful as gravity itself. We sought to understand what it would truly mean to fall into a black hole, to undertake the one-way journey into the universe's ultimate abyss. It started as a silent, almost serene surrender to the inevitable, a cosmic tide pulling you gently from the familiar shores of your own spacecraft. From that vantage point, the black hole was a perfect circle of nothing, a hole punched in the starfield, deceptively calm, its true nature veiled by the elegant simplicity of the event horizon. That boundary once crossed sealed your fate more completely than any prison wall ever conceived. It was the moment space-time itself turned against you, the future becoming a physical direction, a path leading only inward toward a single inescapable point. We witnessed how the universe you left behind would accelerate into a fast-forwarded frenzy, its entire future history, the birth of new stars, the death of galaxies, the final cooling of the cosmos itself, flashing before your eyes. In a fleeting instant, a final blue-shifted message from a world to which you could never return. Inside, your reality became a strange and hostile geometry. The gentle pull became a relentless tidal force, a cosmic inquisitor intent on discovering your breaking point. We watched through the lens of physics as that force seized you, as the difference in gravitational pull between your head and your feet infinitesimally small, at first grew to become an irresistible, monstrous power. This was spaghettification, a term almost comical in its description of a fate so utterly terrifying. It is a process of deconstruction at the most fundamental level. Your body, a marvel of biological engineering, a vessel that carried your consciousness across interstellar voids, was elongated, stretched, and ultimately atomized by the raw curvature of space-time. In less than 1/10 of a second, in that final violent moment before the singularity, you were not simply killed. You were unwritten. The complex arrangement of particles that constituted your thoughts, your memories, your very being was pulled apart and streamlined into a river of fundamental particles flowing into the infinite. This is the raw, unvarnished truth that lies at the heart of a black hole's darkness. It is a place of absolute transformation, where matter and energy are returned to their most elemental state, crushed under the weight of a collapsed star. Yet your terrifying hypothetical demise was not in vain. This journey from the silent approach to the violent atomic dissolution serves as the most extreme test imaginable for our understanding of the universe. For a century, we have been guided by Albert Einstein's theory of general relativity, a conceptual framework of such profound beauty and predictive power that it has become the bedrock of modern cosmology. It is a theory that describes gravity not as a force, but as the very shape of the universe, a dynamic four-dimensional fabric that can be warped, bent, and rippled by the presence of mass and energy. Everything we have witnessed on our fall, the bending of starlight around the black hole, the inexorable pull of the event horizon, the time dilation that separated you from the rest of us, and even the brutal mechanics of spaghettification, is a direct, spectacular confirmation of Einstein's genius. General relativity is the masterful symphony that describes the grand cosmic dance of planets, stars, and galaxies. It predicted the existence of black holes long before we ever saw one describing these gravitational prisons with unerring mathematical accuracy. It foresaw the subtle wobble in Mercury's orbit, explained the gravitational lensing that turns distant galaxies into ethereal arcs of light, and even predicted the existence of gravitational waves, those faint ripples in the fabric of reality 100 years before our technology was sensitive enough to finally hear the universe whispering to us. On this journey, we have seen Einstein's theory perform flawlessly in the most extreme environment we can imagine. It has been our reliable map through a landscape of warped space and twisted time, guiding us right up to the very edge of the abyss. But it is here at the heart of the black hole, in the crushing confines of the singularity, that the symphony finally breaks down. The music stops. The mathematics of general relativity, so elegant and powerful everywhere else, produces only infinity's infinite density, infinite gravity, infinite space-time curvature. These are not descriptions of a physical reality. They are mathematical cries for help. They are the equivalent of a calculator screen flashing error. It is the clearest signal the universe could possibly send us that our most profound theory of the large, our guide to the cosmic scale, is incomplete. Einstein's masterpiece, for all its glory, does not have the final word. It has led us to the edge of the cliff, but it cannot tell us what lies in the chasm below. This failure is not a defeat. It is a magnificent opportunity. It is the frontier of human knowledge, the point where our current understanding ends and a new, deeper reality must begin. The singularity is a gateway not just for the matter and light that fall into it, but for our own scientific imagination. It tells us that to comprehend the heart of a black hole, we need a new kind of physics, a theory that can bridge the greatest divide in all of science. This is the chasm that separates the world of the very large from the world of the very small. It is the conceptual gulf between the two great pillars of 20th century physics, general relativity, the theory of gravity, and the cosmos and quantum mechanics, the theory of particles, probabilities, and the subatomic realm. These two theories are spectacularly successful in their own domains. General relativity reigns supreme over planets, stars, and the expanding universe. Quantum mechanics provides a breathtakingly accurate description of the forces and particles that govern atoms and their constituents. For most of the universe's history, and in most places within it, these two great theoretical empires have been able to exist in a state of peaceful separation, each ruling its own scale without conflict. But in the extreme conditions of the singularity, these two worlds are forced to collide. Here, an immense star-crushing mass is compressed into a space smaller than an atom. It is a realm that is simultaneously infinitesimally small and unbelievably massive. It is both a quantum object and a gravitational behemoth. To describe it, you need both theories at once, and when you try to apply them together, they declare war. They give us contradictory answers. Mathematical nonsense, a universe that is fundamentally paradoxical. This is the central crisis of modern theoretical physics, and the singularity of a black hole is its most dramatic battleground. The resolution to this conflict, the peace treaty between the titanic and the tiny, is what physicists call a theory of quantum gravity. This is the holy grail of modern science, a single unified framework that could describe all the forces of nature from the whisper of a photon to the collision of galaxies within one set of elegant and consistent equations. It would be the final chapter in a story that began with Newton, was rewritten by Einstein, and now awaits its next great protagonist. The search for this ultimate theory is the great intellectual adventure of our time, and physicists are exploring several tantalizing though unproven paths. One of the most famous is string theory, which proposes a radical reimagining of reality's fundamental ingredients. It suggests that if you could zoom in on an electron or a quark with unimaginable magnification, you would find not a point-like particle, but a tiny vibrating filament of energy, a string. The different ways this string can vibrate, like the different notes produced by a violin string, correspond to all the different fundamental particles we see in the universe. In this view, the rich tapestry of matter and energy that surrounds us is nothing more than a cosmic symphony played on these infinitesimal strings. String theory is mathematically beautiful and conceptually audacious. It requires a universe with more than the 3 dimensions of space, and one of time that we are familiar with, perhaps as many as 10 or 11 dimensions in total, with the extra ones curled up so tightly that they are imperceptible to us. Within its complex framework, gravity arises naturally not as a separate force, but as another vibration of these fundamental strings. It offers the tantalizing prospect of a theory, where gravity and quantum mechanics are no longer at odds, but are instead 2 different facets of a single deeper reality. It suggests that inside a black hole, the singularity might be resolved with the infinite point replaced by a fuzzball of strings, a bizarre multi-dimensional object that encodes all the information that ever fell in. Another leading contender is loop quantum gravity. This theory takes a different approach, focusing not on the particles within spacetime, but on the nature of spacetime itself. It proposes that the smooth continuous fabric of reality described by Einstein is actually an illusion. Just as a piece of cloth is woven from individual threads, loop quantum gravity suggests that spacetime is built from discrete, indivisible chunks, or quanta, of space and time. These are the fundamental atoms of geometry, the smallest possible volume, the shortest possible duration. At this foundational level, spacetime is not a smooth stage, but a dynamic, evolving network of connections, a cosmic web of finite loops. According to this idea, you cannot squeeze matter into an infinitely small point, because there is no such thing as an infinitely small point. There is a fundamental pixel size to reality. As a star collapses to form a black hole, it can only be compressed so far before it reaches this fundamental limit, this smallest possible unit of space. At that moment, the inward crush of gravity would be met by an outward quantum pressure of spacetime itself, a repulsive force that prevents the formation of a true singularity. Instead of collapsing to infinity, the matter would bounce, creating what some have called a Planck star. This bounce could potentially create a tunnel through spacetime, a wormhole leading to another part of our universe, or perhaps even to another universe entirely. It is a mind-bending possibility, suggesting that the end of your fall might not have been an end at all, but a violent and transformative rebirth into an unknown realm. These are just 2 of the leading ideas, each a profound and beautiful attempt to write the next chapter of our cosmic story. Whether the final answer lies in strings, loops, or some other idea we have not yet even conceived of, one thing is certain: black holes are not merely cosmic destroyers, they are the ultimate laboratories. They are nature's particle accelerators, crushing matter and energy under conditions so extreme They are far beyond our ability to replicate on Earth. They are gravitational crucibles, where the very laws of physics are pushed to their breaking point, and in their failure they reveal the clues we need to find a deeper, more complete theory. They are the gatekeepers to the quantum realm of gravity, challenging us to look beyond Einstein and imagine a new description of reality. This is perhaps their greatest legacy. These objects born from the death of massive stars serve as cosmic anchors for our imagination, forcing us to confront the deepest questions we can ask. What is space? What is time? Where did the information that defined you go after you crossed the event horizon? This last question, the black hole information paradox, remains one of the most vexing puzzles in all of science. Quantum mechanics insists that information can never be truly destroyed, while general relativity suggests that inside a black hole, it is lost from our universe forever. Solving this paradox is a key test for any potential theory of quantum gravity, as it touches upon the very nature of reality and existence. Our journey is over, but the great adventure of discovery is not. We have travelled to the edge of the known, to a place where the darkness is absolute, and the laws of nature are stretched to their limits and beyond. We have seen how the universe in its most violent and extreme manifestations holds the keys to its most subtle and fundamental secrets. The fall into a black hole is more than a story of destruction. It is a story of revelation. It is a testament to the power of human curiosity, which drives us to ask questions about places we can never go, to understand fates we can never experience, and to build theories that can grasp the unimaginable. The darkness of a black hole is not empty. It is filled with the promise of new knowledge, with the whispers of a more profound reality waiting to be discovered. It reminds us that the greatest treasures of the cosmos are not found in the bright light of stars, but in the deepest shadows at the very edge of our understanding. The universe is under no obligation to be simple or intuitive. Its deepest truths are often hidden within its most extreme paradoxes, and it is in grappling with these enigmas that we push ourselves forward, expanding not only our knowledge but also our very sense of what is possible. The abyss calls to us not as a final destination, but as the next frontier.